In this lecture, we are going to talk about data type qualifiers. Now, data type qualifiers will add some properties to the existing data type, the basic data types that we have already studied. And we have already seen some of the qualifiers in our previous lecture, that is the qualifier signed and unsigned. By using the qualifier signed and unsigned in the integer data type, we actually changed or altered the range of integer data type. Now similarly, we have two more qualifiers that we are going to cover in this lecture, that is short and long. The intent behind having the short and long qualifier is to actually decrease the size of integer or to elongate or increase the size of integer data type. The C standard specifies that integer needs to be of at least 2 bytes long, short is of at least 2 bytes long, and long is of at least minimum it should be of 4 bytes. And short, the size of short should be less than the int, and integer in turn should be less than the long. This is the only rule that is provided by the standard, and therefore compilers are free to choose the sizes and ranges. Therefore in this program we are going to find out what is the size and what is the range for different variations of short and long. So first of all, let's try to declare some short variable. So if I write short int a, so what does it mean is that this is going to be integer, but now it is of type qualifier is short, so it will be of short int. Okay, so short int a, and if I write short b, I can simply write short b. So if I write short b, it means that it is short int b. So both of these, whenever I just write short, it means it is a signed value. Okay, so it is signed short. Okay, so it's signed short int actually. So this is signed short int b. If I have to create an unsigned short int, I have to write unsigned short int, let's say c. This is of short int of type unsigned. Okay, so if I can print the sizes of all these variables, I can just do like this: printf size of, let's say, short int a equals to %d. Okay, so I print here size of a because a is of type short int. Okay, then I'll print, let me just copy this, so I'll just paste it here and paste it here. So size of b, so size of short b. Okay, short b is, this is size of short b, and size of unsigned short int c is size of c. Okay, so let's try to see what it does here. So let me compile this code here, run this code now here, and I see for all three cases, size of short int a, that is size of short int is also 2, size of short is also 2, and size of unsigned short is also, unsigned short int is also 2. Okay, now let me display the range of short int. So in order to display the range, I need to take help of the header file limits.h. In the header file limits.h, the range is already stored there. Okay, so now I just write here printf lower limit of signed short int is %d. So first let's talk about the signed short int. Okay, so I'll write shrt mean. Okay, shrt meaning short. This is signed short int. So this is the one here, and let me just paste it here as it is. Upper limit of signed short int is shrt max. Okay, so let's try this one. Now let me clear this first. Let me compile this and let me run this code here. So I see the lower limit of signed short int is minus 32,768 and upper limit is 32767. Okay, so this is for signed short int or this is for short int. Both are same thing. Okay, just remember that signed short int and short int are the same. Okay, now let's do it the same thing for the unsigned short int. Okay, let me just copy this here to find the range. Now there's no need to remember this. You can always write a program like this to find the range of all these data types and qualifiers. Okay, so if you want to do it for unsigned, you just have to put it here u in front of short, so it becomes unsigned short mean and unsigned short max. So I write it here as unsigned here, unsigned and unsigned. Okay, so let me just clear this screen and compile this first. Okay, use short mean. Alright, so the minimum of short int is, or unsigned short int is not available in the header file limits.h because I know that the minimum of unsigned short int is always 0, right? We already know, this is a fact. minimum of unsigned number is always 0. It starts with 0. Okay, so there is no need to write this. This is not available in limits.h. So I just simply print the message lower limit for unsigned sort int is 0. So I just compile and then run. So I see 0 is the lower limit and upper limit is 65535. Here I have not given the new line here. Therefore, printf the message upper limit is coming in the same line. So in order to get this in the new line, I have to write \n. Okay, so I'll compile this again. Let me clear this and let me run this. I'll get the message in the new line now. Okay, so this is how it works. Now let's talk about the format specifier for sort int. So the format specifier for sort int, let's say the value for a is let me give some value to a. So let's say a is 5, b is -3, and unsigned sort int c is, let's say, 12. This should be a positive number. Okay, so now if I need to print this value, I need to write printf a equals to the format specifier for sort int. So %h is for sort, int is d. So %hd. Similarly, b equals to b is the same thing. It is the signed sort. So I write %hd for signed sort, and c equals to, because c is the unsigned number, so I'll write %h because this is a sort value, h for sort, and u because it's an unsigned value. Okay, so these are the format specifiers I'll be using, a, b, c, and let's just save this and then see how it works. So let me compile this code, and now I see the value here. A is 5, b is -3, and c is 12. Okay, please note down %h is for sort, u is for unsigned, and if it is signed, you just have to give the format specifier for integer, which is d, %d, or you can also write %i for integer. Okay, there's no problem. This is about sort int. Okay, let's now do the same thing for long int. Now let me just copy this code because I'd like to do the same thing for long. Okay, so I'll just copy this code and then comment it by writing control/. Okay, this is commented now. Now I just come down here and then I have to modify a few things here. Okay, so first thing first, I have to make this sort as long. Okay, so let this be long int a. Okay, this is long b, and let this be unsigned long int. Okay, so the qualifier long I've been using here. Okay, so this is obviously signed long int. Whenever I just write long int, it is a signed long int. Whenever I just write long b, it means it's a signed long int b. Okay, and this is unsigned long int c, obviously. Okay, so for the format specifier for long is simple. Instead of h was for sort, now l is for long. So I just write ld here, and then lu here. Okay, long, %l for long. Okay, you can't simply use l. With l you have to either attach d or u. Okay, so first of all, let's print the size of long int a, long b, and unsigned long int c. Okay, similarly, lower limit of signed long int and upper limit of signed long int. Okay, let me just change it here. And signed long int is equals to long int. Both are the same thing. Okay, here I have to write long, L-O-N-G. Okay, similarly here long mean long max. Okay, similarly this is unsigned long, u long max. So now I just need to compile this here, clear the screen, and I have to compile this and then run it. And then now I see, you just come here, the size of long is 4 bytes. Size of sort was 2 bytes. Size of long in my machine is 4 bytes. Okay, it did not elongate int in my case, but if my machine was a 16-bit machine wherein my integer was, let's say, 2 bytes, in that case long would be 4 bytes. That would be an advantage. But in my system, long is also 4 bytes, integer is also 4 bytes. Same thing. Okay, and the size is given here for signed and unsigned. Okay, now for unsigned long int, I am getting this size, this upper limit, that is the maximum value, as -1. So I need to actually modify this. Okay, because I am talking about the format specifier needs to be changed here. So upper limit for unsigned long. What is unsigned long? So I have to write LU for unsigned long. Okay, small LU. So I'll write %LU for unsigned long. Similarly, signed long is what? I can write LD. Okay, this is signed long LD. So here I make the appropriate changes, okay, and then now I can run this. So now you get the real upper limit and the lower limit, okay. So there was a problem here, now this is fixed here, okay. So this works fine. Now let me comment this here, okay. Let me copy this first and then comment this here, okay. Now I have one more kind of a data type here. That is, by using long, I can get one more kind of a data type, okay. What is that? Is I can have something called as long, okay, longer than the long, okay. So this is signed long int. If I write long, it is signed long int, okay. I can write long space long b. So it is actually signed long b, int b, okay. So it is unsigned long. So I can have signed and unsigned version of long also, okay. Now long is actually longer than, actually double the size of long, okay. Let's see what would be the size here, okay. Now for long, it's very simple. I have to put this L 2 times, long LLD long int, and LLU is long unsigned int, okay. So similarly long, let's just change this print values, okay. Long unsigned long, other things are the same thing, okay. Now if I am printing the long, okay, so let me just replace this by long, okay. Now here you have to write LL mean LL max, okay, ULL max. Compile it, we run it, and you see now we have to again change the format specifier here, obviously LLD, okay, LLD and LLU, otherwise it will not support. So again, let me just clear this first and then compile and then run. So now you will see the real. Now you see how much of elongation has happened. Okay. So size of long actually is 8 bytes. So 8 bytes is as good as 64 bits long. Okay. So it is a very big number it can hold. So this is how small the signed long int minimum value can be, maximum value. And when you go to the unsigned long, even you will be able to store the larger number, right? So as per the requirement for your program, if you are working for some scientific project wherein you have to store a very big value or a very small value, then you have to choose your data type and qualifier appropriately. That's the reason we are actually covering this, and there is no need to remember all these. You can always write a program to check what is the size and what is the range for each of your data types and qualifiers. Okay, now there's one last thing that is remaining. There's one very important thing that's called as long double. Okay, so this is one more very important data type that you can have using long. Okay, long goes with double, so it's called as long double. So if I have long double, let's say data type variable name is x, and I'll just print size of long double is %d. Let me just print this size. Now size actually is a number, right? Size will always be a positive number, so it's better to write unsigned here. This is a better way of writing because the size will be a positive number, so this is unsigned integer number. Okay, so I'll just write size of long double. So let me just comment this upper part here because I don't need it right now. The commenting is done. Now let me just compile this code here and run it. So say it's 16 bytes. So 16 bytes is a very big size. Okay, now size of long double depends upon different computers. Some of the computers systems may have long double as 10 bytes long. Okay, in my case it is 16 bytes long, so it is the precision is higher than the double. Okay, it's called as quad precision is actually double than the doubled. So it's a very interesting data type. Okay, we are not going to print the lower limit and upper limit of this. Okay, but just to note that if you have to need a very long double number, then you can use long double as well. Okay, so this is all about the type qualifiers. And for long double, the format specifier is you can just note it down. It is %LF, both capital letters. %LF is the format specifier. Okay, it's a format specifier for long double. Now I've summarized this entire thing in a tabular form here. You can see the data types here in the first column. The format specifier is specified here, the size and the minimum and maximum value, right? The reason why I've done this table here is you need not actually remember the minimum and maximum range. You can actually derive it, right? We've already discussed for the signed integer. For the signed integer value, we have already derived the formula. The range would be -2 to the power n minus 1 to plus 2 to the power n minus 1, where n is the number of bits. Okay, here number of bits is given. If it is 16 bits, The minimum value is minus 2 to the power 16 minus 1, that is minus 2 to the power 15, which is equivalent to, you can use your calculator to find, the value would be minus 32,768. Similarly, to find the upper range, you'll have to use this one, that is plus 2 to the power n minus 1 minus 1. If you look at it here, it is 2 to the power 15 minus 1, and this would be the value. For unsigned number, it is 0 to 2 to the power n minus 1. So it is 0 to 2 to the power 16 minus 1 here, because it's 16 bits. Right? And this is how it's being derived. Okay, there's no need to remember all these values. So if you're not clear on this, how the range is being derived, you can go to my lecture on essential fundamentals section, that is section number 2. You'll be able to find out the details. Okay. So with this note, I'm going to end this lecture. I hope you have learned about the data type qualifiers, what is the minimum and maximum range of different data types, and even the format specifiers, and you should now be comfortable using these data types. So please make use of these data types and qualifiers, and while actually declaring a variable and deciding about your variable, make sure that you'll choose a data type which is appropriate for your variable. Okay, so that's all for this lecture. Stay tuned.